We're going to now today talk about systems of equations. All that means is you're dealing with more than one equation. So it's equations that come together to form a system. So it's when two or more linear equations form a system. So if you're asked to graph basically more than one line, that's what we call a system. So if you graph 2 lines, 3 lines, 4 lines, you're graphing a system. A solution of the system is any ordered pair that is solution of each equation in the system. That really doesn't make any sense to you all. So a better way to say it is where they intersect. So you're looking for their intersection point. And that's going to tell you a coordinate point that solves both equations. So basically you're going to figure out the x and the y that satisfies both equations. Make sense? All right. So the nice thing is there's only 3 steps. And really step 1 and they're all kind of repetitive. But your first step is always going to graph. So if you're still struggling with graphing, you might want to have out your 9-1 notes. But your first step is to graph each line. Today we're only looking at 2 lines. Typically that's all you'll look at. But your first step is going to be graph. So I would like you to graph y equals negative x plus 1 and y equals 2x plus 4. If you get confused and you want to use 2 different colors, like maybe a pencil line and a pen line, that's fine. But you don't have to, just if you got confused. So right now you should be graphing 2 lines on your graph right here. So go ahead and graph those 2 lines. Hopefully if you graphed correctly, your graphs look super similar to mine. Hopefully if you graphed correctly, yours looks almost identical to mine. If yours doesn't, you've made a mistake somewhere and you need to figure out where. Yes, ma'am. Negative 1 over 1. Okay, so hopefully when you graphed, you got them to look super similar to this. Almost identical. Okay, so the second step, all you have to do is find the point of intersection. And so my point of intersection is negative 1, 2. Yours should be the same. That's what we call the solution. That x and that y should solve both of those equations. It should be a solution to both of those. I should be able to plug that into both those equations and it works. So that's what we mean by solution. So we're saying that this x and this y should be able to go into this equation and work for both of them. So, and to be a really good mathematician, your third step is always going to be to check. Now, I understand some of you don't like checking, so it's up to you if you use this step, but if you are to miss it or get it wrong on a test or a quiz or even homework, I'm going to say, did you check it? So let me show you how to check it. So I'm going to do the first one and then allow you to do the second one. So I'm going to check to see if it works for y equals negative x plus 1. I would highly recommend writing this down with me. So, Harrison, what is my y value? What do I claim my y value is? That's a solution. 2. So instead of y, I'm going to put a 2. 2 equals negative, x is negative 1 plus 1. Everybody with me so far? Yes, ma'am.
Wouldn't that be a positive 1?
Yep. Because those 2 negatives make a positive? Yep. So 2 equals 1 plus 1. Does 1 plus 1 equal 2? Yes. So that's a check. If it didn't work, I would know it's not a solution. Now, it should be a solution for the other one also. So it should be a solution for y equals 2x plus 4. So instead of y, I put a 2. Instead of x, I put a negative 1 plus 4. 2 equals negative 2 plus 4. 2 equals 2. That's a check. You should be able to check both and it work. If it doesn't, your point of intersection is not right. Does everybody understand that? The first two shouldn't be difficult. The third, and it's completely up to you if you check. I'm just telling you that's the way to make sure you're right. All right, at your table, do the bottom one. At your table, do the bottom one with your table partners, please. Hopefully, if you have done it correctly, you got 2, -4. Now, one thing I want to talk about. This one, you started at -6, and it was going to go off, so you just needed to go up 1 over 1, up 1 over 1, up 1 over 1. The second one, the y-intercept was 0, and then it was negative, so I went down 2 over 1, down 2 over 1. They met at 2, -4. Now, if we wanted to, we could check it. Now, this one's easier to check because there's not as much math involved. So, y is -4. 2 minus 6 is -4. That's a check. This one, y equals -2x. So -4 equals -2 times 2. -4 does equal -4. That's a check. Checking can be super helpful because a lot of you just looked and were like, oh, I got it wrong. If you checked, you would know your point of intersection wasn't right. All right, let's flip to the back. Now we're going to look at what we call special cases. There's going to be situations where the lines don't meet or where the line is the same line. So we're going to look at both the special cases on the back. Yes. Then you would want to find where all 3 lines meet. Okay, that's why we call it system. It can be as many lines as someone asks you to graph. All right, graph the following. X plus y equals 1 and y equals -x plus 3. So the first one you're going to have to get y alone. So you have to get y alone. You all know how to do that. But this one's ready to graph. So right now at your table, graph both of those lines. Graph both of those lines. Hopefully, if done correctly, you have graphed 2 parallel lines. So this one, when I rewrote it, I got y equals -x plus 1. So I went to 1, and then up 1 over 1, up 1 over 1. So this one looks like this. The next one was 3, and then up 1 over 1, up 1 over 1. Hopefully you got 2 lines that are parallel to each other. Hopefully. When 2 lines are parallel, they're never going to intersect. So when this happens, we say there's no solutions. There's no point that's going to satisfy both those equations because they're never going to intersect. So we call that no solutions. All right. Now I want you to graph the next 2. Both of those you have to get y by itself. So I'm going to give you a couple minutes to graph both of those. A cool little link between these 2. Hopefully if you've done it correctly, you have figured out it's the same line twice. So hopefully when you solved this, you saw that they both solved to y equals 1/2 x plus -2. Hopefully. And I can solve them if we didn't get that. Okay, so let's solve this first one. So the first one was x minus 2y equals 4. So I subtracted x. I get -2y equals -x plus 4. Divide by -2. Divide by -2. So those cancel. Y equals a negative divided by a negative makes a positive. 4 divided by 2 is -2. So when you get something like that, it's the same line for both of them. So we had -2, up 1 over 2, up 1 over 2. Any number is going to be a solution. It's the same line. They intersect the entire time. So we say this has infinitely many solutions. In other words, every number is going to work. Yes?
With 1/2 x, go positive.
Because a negative divided by a negative makes a positive. So, equations like that, we say there's infinitely many. The whole point in systems is to find where they intersect. These are just special cases. They don't happen very often, but when they do, you need to know that. But really, all you're doing is graphing 2 lines or more than 2 lines to find where they intersect. Everybody good? Okay, since it's Friday,